Good morning, all of you. Today, I would like to tell about the force analysis on gear tooth. So, this force analysis on gear tooth is very important. So, because if we want to analyze the gear tooth and what are the forces acting on the gear tooth, so these forces are we have to understand what are the types of forces and what are the force components those are acting on the gear tooth. Okay. So, let us see in detail step by step. So, here from the figure 1 we see the gear tooth force diagram on gear tooth force. So, this diagram shows that there is, so here from the figure 1 which shows the gear tooth force, so here the pinion driver, the pinion as well as the gear are in mesh with each other. So, here we can see that, so the pinion is the driver and the gear is the driven gear, and for power transmission, so the, because the pinion is the driver, so the force will be exerted by the pinion teeth on the gear teeth. So, and also we can see from the figure there is an important point that the pinion is rotating in the anti-clockwise direction and the gear is rotating in the clockwise direction. So, here you can see the pressure line, so that is there between the tooth of the pinion as well as the gear. So, the pressure line is the line on which the resultant force is acting. The pressure line indicates the resultant force which is acting on the tooth. So, for and also you can see pressure angle. So, alpha is the pressure angle. So, that is the angle between the this tangent line to the pitch point and the pressure line. Okay. So, that is the angle alpha, and also there are some valid assumptions in gear tooth force analysis. Okay, let us see these assumptions in gear tooth force analysis. Okay, so if we see here one important point we have to note, that is, so when the pinion teeth is in contact with the gear teeth at the pitch point, okay, so the resultant force varies. The contact point varies. The contact point between the pinion teeth as well as the gear teeth varies, and so the resultant force also varies. But this resultant force variation is neglected in the analysis. That is first assumption. So, first assumption is resultant force is not varying. So, that is the first assumption. And also another important assumption is, so generally in reality, so only one pair of tooth not in contact with each other. Okay, so there may be two pairs of tooth or three pairs of tooth while the pinion and the gears are meshing with each other. So here we are assuming only one pair of tooth are in contact in this force analysis. And the other assumption, so here at the pitch point the resultant force is varying, so the force is dynamic here, but in reality the force is dynamic, but here we are assuming the static force analysis. So, that is the third point. So there are three important assumptions. One is the contact point is not constant, so contact point is varying, as well as the one pair of teeth is in contact with each other. That is another assumption we have taken. And static force analysis, because the forces between the meshing teeth may be dynamic in nature, but we are neglecting that in our force analysis. Okay, so now let us go to this another slide so that we can see how the forces are acting on the pinion and the driver. Okay, so here we can see the pinion is the small gear, and rotating in the anti-clockwise direction, Okay, and here gear is the bigger diameter wheel, and we can have this is clockwise rotation of the gear from the figure. And also, so while the pinion is the driver in power transmission, so what happens is that the pinion is exerting some force on the gear tooth. So what is the force exerted by the pinion on the gear tooth? So that is important for us. So here the total resultant force, that is Pn is the total resultant force. Pn is the total resultant force. So that is again resolved into two components. So that Pn is resolved into two components. One is Pt, that is tangential component, and another one is Pr, that is radial component. Okay, so here Pt is the tangential component, and this one is the radial component of gate tooth force. So now for power transmission, so what is the important component that is responsible for power transmission? So because there should be the movement or power transmission between these two gate wheels. So how the movement will be established? So by this tangential force only, so that can be established, but radial, so this is responsible, Pt responsible for power transmission, while this radial component is a separating force. You can see from this diagram easily. Okay, so in this components of tooth force, figure 2, so if you observe here, so this is the pitch point, okay, on the geared wheel, and the force exerted by the pinion on the gear wheel at the pitch point, that is given by Pt. So and also the radial component exerted by the pinion on the gear is given by this Pr. And similarly, if we see the forces acting on the pinion, so here the radial component is acting quite opposite to this direction of this Pr. Okay, and also this Pt is again given by the force exerted by the gear on the pinion. Okay, so these are the components of forces of the resultant force, that is Pn acting on the gear and the pinion. Okay, so now let us see what are the equations we can get by this diagram. Okay, so here we know for power transmission, we know that torque is very important. So torque is very important. So torque is given by, there is one formula, a famous formula, we know that one. Okay, so Pmt is equal to 60 into 10 power 6 in kilowatts, power in kilowatts, by 2 pi n. Okay, so this is, let me write this one again. So that is 60 into 10 power 6 in kilowatts, okay, by 2 pi n. Okay, so this Mt, this is the torque. So Mt, that is the torque responsible for power transmission, and this torque is given by this formula in Newton mm. Okay, so Newton mm. So you can see this torque. So how can we obtain this torque now? So this torque can be obtained from this diagram. So Mt is the Pt, so the force into perpendicular distance. So what is the perpendicular distance? That is, if we consider the pitch circle diameter of the gear or tooth, gear or pinion. Okay, so Pt into d dash by 2. So that is the formula for this torque. So how can we get this torque? Okay, so now we can get this Pt is equal to Mt into 2 by d dash. Okay, so this is the tangential force. Okay, so the tangential force or the tangential component of force 2 into Mt by d dash. So that is the tangential component of force. So in the similar way, from this diagram we can obtain this tangential force of component. Okay, so here we can see from this diagram, from figure 2, so cos alpha, so that is adjacent side by hypotenuse. Okay, so what is the adjacent side here? So Pt by hypotenuse, that is Pn. Okay, so now we can get this Pt in terms of Pn cos alpha. Okay, so this is also one important equation, so that we can use in problems. Okay, and also now we have another equation, so that is tan alpha. So we can obtain from this diagram. So tan alpha is equal to so opposite side by adjacent side. So opposite side, that is Pr by adjacent side, that is Pt. Okay, so now we can obtain the radial component of force, that is Pt tan alpha. Okay, so this is another equation. So we can obtain this components of force in this manner, if we know the pressure angle, so how it is acting, on the pinion and the gear, so this will be very much helpful. So once we calculate this PT and PR, so we can obtain this torque. If we know this PT, so then we can obtain this torque that is generated. So torque into power, if you want to calculate, so then torque MT into omega, so that will give you the power. Okay. So in this way we are calculating the power transmitted between the pinion and the gear by gear tooth force analysis. Okay. So let us just go to the next slide, and we can see if the pinion is in rotating in the anti-clockwise direction. So now the force will be exerted by the gear on the pinion, so in this direction. So because this anti-clockwise direction of the pinion is there, so the tangential force of this exerted by the gear on the pinion will be quite opposite to the rotational direction of the pinion. So in the similar way, if we see here the opposite force that is there, that PT is there, so that is quite the opposite to this PT acting on the pinion. Okay. So in this way, so you can do the gear tooth force analysis, and this will be helpful for calculating the power transmitted between the gear and the pinion. Thank you very much.